Hello everyone, I am Dr. Raman. In this section we are going to discuss with the diagonalization of matrix by orthogonal transformation. Let A be a symmetric matrix. A be a symmetric matrix and N be the matrix whose columns are the normalized eigenvectors of matrix A. If we consider x is an eigenvector, x1, x2, x3, this is an eigenvector, then how to find the normalized vector of x? Then the normalized vector of x is, we consider x bar. This is a normalized eigenvector. We consider the notation x bar. Now x1, how to find the normalized vector? x1 divide by x1 square, x2 square, x3 square. The each column take the square root. Then x2 divide by square root of x1 square, x2 square, x3 square, and then x3 divide by x1 square, x2 square, x3 square, square root. So this is our normalized vector of x. Since N is orthogonal, we use N inverse equal to N transpose. Then D is a diagonalization of the matrix. So D equal to N transpose A into N, which is called orthogonal reduction. Orthogonal reduction or orthogonal transmission. So now some note: A symmetric matrix, A symmetric matrix, orthogonal transmission, is possible only for real symmetric matrix. Now we are going to solve problem. Now the problem is nothing but diagonalize the matrix A. So the matrix given 3 cross 3 by an orthogonal transmission. Now first procedure, how to solve this? As usual, similar procedure. The earlier we have discussed how to find the eigenvalue, eigenvector. Same procedure. First step, characteristic equation A lambda A minus lambda I determine 0. The form 3 minus lambda minus 1 1 minus 1 5 minus 1 1 minus 1 3. So this 5 should write it the form 5 minus lambda, this diagonal 5 minus lambda 3 minus lambda, take this determinant equal to 0. Now when I expanded this determinant 0 characteristic equation, it coming with cubic polynomial lambda cube s1 lambda square plus s2 lambda s3 0. Now already we solved this related similar problem. So anyway, we repeat again the process. So first to calculate S1. S1 is nothing but sum of the main diagonal elements. So what is the diagonal elements? So this is the main diagonal element. Therefore 3 plus 5 plus 3, now 11. So S1 is 11. And then S2. S2 is nothing but sum of the minor of main diagonal elements. Main diagonal elements. So first diagonal I'm going to choose this. So what is the first diagonal? This is the first diagonal, 3 main diagonal. Now to find the minor matrix, how to find this? To leave this row and leave this column. Therefore this is our minor matrix 5 minus 1 minus 1 3 plus. So next diagonal, next to matrix, next to diagonal 5. So when I'm choosing 5, now again to leave this row and leave this column. Now we have the minor matrix 3 1 1 3 plus the third diagonal. I'll choose this 3. Therefore to leave this row and column. So when to leave this 3 minus 1 minus 1 5, this is our determinant. Now to find this 2 cross 2 determinant value is nothing but 15 minus 1 plus 9 minus 1 plus 15 minus 1. Therefore 14 plus 8 plus 14. So it's 36 S2 value. Then to find S3. S3 is nothing but determinant of A. So 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3. So this is a determinant. So this determinant in the previous video I have updated through manual expansion of this form and another form to directly use the calculator. So when we use the calculator, the value is nothing but S3, the determinant 36. 36. If you are solving manual, so you take 3. So how to take this? I'll show the manual, or if you are using calculator also fine, use calculator. Very simple steps to solve this. And we consider this when I'm choosing this first row, then plus minus plus minus plus minus plus minus plus. This is the structure of this determinant. Now plus minus plus, when I'm consider the first one to take this 3, when leave the column and row 5 minus 1 minus 1 3. then next to minus sign, minus of minus plus 1, then minus 1, 1, 3. To leave this, check this, to leave the column and row. Then next to 1, we'll leave the column and row, minus 1, 5, 1, minus 1. Now this 3 into 15 minus 1 plus 1 into minus 3 plus 1 plus 1 into 1 minus 5. Therefore 3 into 14 plus 1 into minus 2 plus 1 into minus 4. Therefore the value is nothing but, so 14 into 3, 42 minus 2 minus 4. So 36 S3. Therefore S1, the value is nothing but, S1 is S1 11, S2 36 and S3 36. S1 11, S2 36, S3 36. When I applied this cubic polynomial, lambda cube, S1 lambda square, S2 lambda, S3 equal to 0. Now lambda cube minus 11 lambda square plus 36 lambda minus 36 0. So now this cubic polynomial, use the long division method or use direct calculator to find the value. So when I am using the calculator, directly equation form. So now this polynomial or manual, the coefficient of this term 1 minus 1, 36 minus 36 I am taking. Now I am going to take number 1. When this 1 I am taking 1 into 1, 1 minus 10, 1 into minus 10, minus 10, then 26. So 26, now minus 10. This is not 0, therefore this is not the root. Now you try for another number, minus 1. So next I'll try this, 11, 36 minus 36, minus 1 when I'm trying, minus 1 into 1, minus 1, minus 12, then plus 12, then it's coming with 48, minus 48, now again it's not coming 0, therefore to take another number, so I tried 1, minus 1, then 2 I'm going to try here. When I'm taking 2, then 1 into 2, 2, this is a minus 9 and then minus 18, so this is a plus 18, 36, 0, when equal to 0, this is a one of the roots. Or use calculator is a very simple steps to follow. Directly you will be get the equation option, so degree 3 you will be get the direct answer. So now next I am going to take this next number, so lambda equal to, now the 18 will come, so I'll just try 3 into 1, 3, minus 6, minus 18, 0. Just trial and error we should try. Next lambda 6, 6, 0. So we have eigenvalue lambda 2, 3 and 6. So this is our eigenvalues. And then we just find out the eigenvector. So what is the eigenvector? The form is nothing but so A minus lambda I eigenvector to find A minus lambda I matrix, then x 0, and to write this matrix A minus lambda I, then x is nothing but x1, x2, x3, then 0. Now when I'm writing this equation, we have three linear equation. To write this, 3 minus lambda into x1 minus x2 plus x3 0, then minus x1 plus 5 minus lambda x2 minus x3 0, then x1 minus x2 plus 3 minus lambda x3 equal to 0. Now I consider equation 1. Now first eigenvalue, the eigenvalue lambda equal to 2. So substitute first eigenvalue lambda equal to 2 in 1. We have three linear equation. When I substitute 2, then x1 minus x2 plus x3 0, then minus x1, then when I substituted here 3x2 minus x3 0, then x1 x2 plus x3 0. Now choose any two equation, but the problem is 1 and 3 don't choose because of both equations are similar. Therefore to choose 1 and 2. When I'm choosing 1 and 2, x1 minus x2 and x3. To find this, when I'm consider this x1, correct? So when I'm consider this x1, so we have to take this part I'm going to take minor matrix. Therefore what is a minor matrix of this? When I'm choosing this x1, this our minor matrix. Therefore minus 1 1 3 minus 1, or directly to write this cross multiplication. Then x2, when I selected x2, then this is a form. x2 is 1 1 minus 1 minus 1. Then x3, this is x3, then 1 minus 1 minus 1 3. So when finding this 2 cross 2 determine x1 by 1 minus 3, then minus x2 by minus 1 plus 1, then x3 divided by 3 minus 1. Therefore x1 by minus 2 minus x2 by 0, x3 by 2. Now the common factor 2 should write the form minus 1 0 1. So this is a, when lambda 2, the eigenvector is nothing but minus 1 0 1. So this is the first eigenvector. And then second eigenvector lambda 3. So any order to find. Now I'm taking here lambda 3. This is a second eigenvalue. This substitute in equation 1. So we have three linear equation. In this linear equation, to substitute 3, now 0 x1 x2 x3 0, then minus x1 plus 3, when I substituted here 2x2 x3 0, x1 x2, then 0 x3 0. Therefore choose any two equation. Compared to this 1 and 3 similar, so I'm going to choose 1 and 2, x1 by minus x2, then x3. So better you just directly to write the cross multiplication. So what is the cross multiplication of this? This cross multiplication and then this cross multiplication. So minus, this is a 1 minus 2. Then when I selected x2, 0 plus 1. Then x3 when I selected 0 minus 1. Therefore x1 by minus 1 minus x2 by minus 1, x3 by minus 1. Now when lambda 3, to cancel this, x2 equal to minus 1, 1 minus 1. Then lambda 6 in one equation substitute. Therefore we have this linear 3 cross 3 linear equation. 6 when I substituted, minus 3x1 plus x3 0. Then when I substituted 5 minus, so 6 minus x2 minus x3 0, x1 minus x2. When I substituted lambda 6 minus 3x3 0. So now you look at this, choose any two equation. When I selected 2, x1, x2, x3. So when x1, 1 plus 1, x2, 3 plus 1, then x3, 3 minus 1. So x1 by 2, x2 by 4, x3 by 2. So 2 is the common factor. Therefore x1 by 1 minus x2 by 2, x3 by 1. Therefore lambda 6 x3 equal to 1 minus 2, 1. So this is a 3 eigenvector. Sorry, this is a not minus, this is a plus. Therefore this term is minus. So when to remove this minus, to remove, then only for this plus, all the terms are plus. Now x1, x2, x3. So 3 eigenvector. To find this 3 eigenvector to normalized vector, because I want to calculate normalized one. Therefore for this term, to find the normalized vectors, x1 minus 1, 0, 1. So this is a x1. When I find this normalized vector, x1 bar equal to minus 1 divided by minus 1 square, 0 square, 1 square, then square root, and then 0 divided by minus 1 square, 0 square, 1 square, square root, then 1 divided by minus 1 square, 0 square, 1 square, square root. So similar this form, minus 1 by 1 square, 1 square, 1 plus 1, 2, root 2, 0, 1 by root 2. So this is our normalized vector. Now x2 is nothing but 1, 1, 1. Now x2 normalized vector, 1 by 1 square, 1 square, 1 square, square root, then 1 by 1 square, 1 square, 1 square, square root, then 1 by 1 square, 1 square, 1 square, square root. So this is our normalized vector. Therefore 1 by root 3, 1 by root 3, 1 by root 3 normalized second vector. Then x3 1 minus 2 1. So 1 by 1 square minus 2 square plus 1 square. So this is a x bar, normalized eigenvector. So minus 2 by 1 square minus 2 square plus 1 square square root. Then 1 divided by 1 square minus 2 square plus 1 square square root. This is our normalized vector. So this is a 1 by root 3 minus 1 by root 6. 1 by root 6 minus 2 by root 6, 1 by root 6. So this is our normalized eigenvector. Now you combine all the normalized eigenvector. N is combined normalized eigenvector matrix form. So therefore this is a minus 1 by root 2, 0, 1 by root 2, 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 6, minus 2 by root 6, 1 by root 6. Now to calculate n transpose. N transpose is nothing but row to column. So first row change to column. Second row change to column. Third row change to column. Now what is the orthogonal transmission? The diagonalization is nothing but D equal to n transpose A into n. Now n transpose, first you just multiply an, then an transpose. So n transpose, so this is our n transpose. You just substitute n transpose value, n value and A matrix. This is a n matrix, n transpose matrix. Then A matrix. A is nothing but 3 minus 1, 1, minus 1, 5, minus 1, 1, minus 1, 3. Now n normalization. So what is the n? To select this is our n. So when we should do any manual multiplication, first you multiply an, so second part, so otherwise you will not get solution. First you multiply this an, and then after getting the answer, first you this term, then you multiply with n transpose, or directly to use the calculator. This calculation, the 3 matrix multiplication, how to do it, I just one video already updated. Please refer the video. In this video, entire calculation how to do using through calculator I just posted. Please refer before this. It will help you for finding the calculation. Otherwise, when you are doing manual is lengthy procedure. To try to avoid this, use direct calculator. When we are calculating this, we will get the solution. The solution is very simple. Whatever you have the eigenvalue is diagonal. So 2, 3 6. This is our 2 3 6. This is our answer, diagonalization. Thank you.